Hey everybody, Ms. Dietrich here. This is instructional video number 3. Do look for 1 and 2 for lesson 5.1. And they're asking us here, what percent of the image is shaded? And if they want percent, if they ask you percent, that means they want to know some number, some value over 100. Now we can use proportional reasoning to figure this out, because the bottom number would be the all of it number, and the top number would be the part. So I like to even put the words parts in wholes, or part and all. I think most teachers like the word whole, so let's use that. All right, now if we figure out what the all of it number is here, 1, 2, 3, 4, 5 squares going that way, and 1, 2, 3, 4, 5 squares going that way, the all of it number is 25. Now let's figure out how many they have shaded. 1, 2, 3, 4 by 3, so there's 12 shaded squares here. All right, now if we use proportional reasoning and we take advantage of the fact that 25 is compatible with 100, we would just multiply this by 4, which means we'd multiply this by 4. And if we do 12 times 4, and if you don't have it in your head, then do the algorithm off to the side like this, right? We're going to get the 48. So if you have a number over 100, that easily converts to 48%, because remember, this symbol and the act of having this under something are the same thing. 48% of it shaded. All right, let's take a look at a different question. Actually, let's skip that when we come back, because I want to get into the ones where, let's look at number 3. It says shade 25% of each model, then write the fraction of the model that is shaded. Now, this one right here, this probably wouldn't be too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10. So we would just shade in 2 of these things, which I'm not going to do a very neat job because that would waste time. And then 5 of these. So 1, 2, 3, 4, 5. We would shade all that in, and that would be 25%. But how would we do it for ones where the numbers aren't compatible? Now remember, 25%. It means 25 out of 100. And doesn't that simplify to being 1/4? Which means if we shade in this, 1/4 of this, right, in simplest form, 1/4 versus 25 out of 100 not simplified, those two things are the same thing. All right, let's take a look at this one. What's the all of it number? We really need to find that out. 1, 2, 3, 4 by 1, 2, 3, 4, 5. So the all of it number is 20. And if we're talking about shading in 25%, or remember that's equal to 1/4, 1/4, how would we figure out this value right here, right? How would we figure that out? Because this is equal to 25%. Well, would it be kind of the same idea of what we have over here? See, let's just shade it in and compare what we have shaded. So if we shade all of this in, that's equal to 1/4. Is this still equal to 1/4? Because don't we have 1, 2, 3, 4 chunks that size in the all of it value? Well, how many of the little squares is it? If we count the little squares, it's 1, 2, 3, 4, 5. And doesn't it make sense that if we were to solve for the question mark, it would be 5? Since this times 5 is 20, 1 times 5 would give you the answer, which is 5 out of 20, which is equal to 25%. All right, let's take a look at another example. We're not going to have time because we have a kind of a cutoff, a 5-minute cutoff. Now, I think let's even look at this one first, because here they're talking about 35%. So remember, 35% is the same thing as 35 out of 100. 35 out of 100. So we might look, let's simplify this. Let's divide that by 5 and get 7. Let's divide this by 5 and get 20. So it's equal. 7/20 is equal to this. Now, let's look and figure out what's the all of it number, because in this case, all of it is the bottom number, or the whole, and the top number is the part. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So the all of it number would be 25. So to finish this, and we're going to be out of time, you would solve for this number right here to get how many you would need to shade, because they want you to shade 35% of it.